Hi everyone, welcome to the module 12 of the CH course that we've been going through. Today we are going to talk about IDS, firewalls, and honeypots. So, IDS actually stands for Intrusion Detection System. So, participants who have joined us would, after joining it, you will be able to describe the IDS, firewall, and honeypot concepts. Then, some of the solutions that we would discuss during this session, how to use them. You'll be able to explain some techniques which you can use to bypass IDS and firewalls, and some of the tools that you can use to do that. Also, we'll discuss some techniques using which you can detect honeypots. Evading honeypots is a little difficult, and there is no use of evading the honeypots, just to sidestep them and to know that they are honeypots. Then you will be able to perform pen testing activities with respect to IDS and firewalls. Some of the topics that we are going to cover, we'll cover the concepts, some tools, and then evading, even the tools that help us in evading, then detecting honeypots, and how to use all of these in pen testing. So what actually IDS is? So let's say you as an attacker are scanning a network or doing other uh, activities after, even after scanning and gaining a foothold. You want to execute a malicious payload, so you have to upload it or maybe download some files. Whatever activities you do, you would how what if someone is actually monitoring those activities? So IDS is one kind of a system that analyzes that network traffic, and it discovers the intruders as well as the attackers. So major activity of an IDS is to actually monitor and send some kind of an alert based on the rules that are configured in that system to the administrators of the organization. So they just that is also called like flagging normal activity. Okay. So an IDS actually has three components. Okay, let me just scroll it up. Uh, so one component is called NIDS, which is the Network Intrusion Detection System. So job of NIDS is to parse the network traffic, and it is usually installed in the same subnet as the firewall is present. Then it has the rules and a way of actually matching the traffic with some known attack methods. So they have a database, and that the particular database is accessed based on the rules, and then traffic is matched against that. Then something which is similar to NIDS is network node intrusion detection system, which also passes the network traffic, but rather than monitoring the whole subnet, it actually monitors a single host. Okay, it's pretty much same concept, but the focus is different. Okay, and also it is designed to discover the change in the file system, okay, of the host. Then there is a component called host intrusion detection system, which is specifically created to monitor the host. So normally what happens in case of HIDS is that a snapshot is taken of the file system, and after some time, when network activity has happened or over a few days or whatever the policy says, a new snapshot is taken. So then these snapshots are compared with each other, and it is useful for those kind of systems wherein the configuration files have very less changes. Okay. So now, if this is like simply for you to, it's very difficult for you to understand. then having just basic understanding also is fine about the IDSs. Okay. So if there is some jargon that you think is too much to take, you can actually raise a hand or ask for more explanation. Okay. Then there is something called, like, what you should know, like like as an attacker, if you are there inside a, you want to attack a network, and somehow you are able to detect, or you never know whether an IDS is actually monitoring the activities or not. So that is why we keep on saying that please do not run nmap scans, or try to create malicious activities without taking the permission of another, because it is illegal. And intrusion detection softwares are, and the systems are the one which are actually installed in some kind of a demilitarized zone, wherein the only the part that is facing the internet actually is not the real part of a company or an organization. Okay. uh, and the real systems, like the mail servers or any other application servers, are behind these IDSs and firewall. So whenever you do some kind of an activity, these IDSs software look for something, like okay, how do they understand an attacker? So they usually look for scans of open ports. Then if there are some missing or truncated log files, they look for that. So if there are some log files or missing files, it means some a system was compromised, and some malicious activity has happened. Also, it monitors any lagging which happens in the system performance in real time. Okay. And then if there were some probes that have happened on some remote host in the network, okay, if that has happened, they look for that. Then if there are some new files or commands on the system, so if that is there, it means someone has tried to upload some kind of a payload, right? And or if maybe someone has tried to open some kind of a backdoor. So then it also looks for unusual log file entries in the application logs. Okay, then if there have been some repeated login attempts with whenever we try to brute force, so any repeated login failed attempts also are looked for by the IDS. Then there are some missing files if they are there, and also the changes in the size of the binary files. So these are also looked by IDS software. Okay, and then let's say what firewalls are. So there you will, whenever you have a discussion about somebody, or whenever you read about these, so you'll find that there are actually two types. Okay, so it can be either hardware based firewalls or software based firewalls. So generally, you would see that installing or putting hardware-based firewalls is usually faster. Okay, and for a software-based firewalls, it takes a little bit of time to configure them, to learn them, and to train others. Okay, so but there is some kind of a con with the hardware-based one, because and they are not flexible enough, and you cannot do some modifications. It's like the way you purchase a computer, or like it's like a device, like some switch similar to which looks similar to a switch kind of a device. Okay, which has a lot of ports, and cables actually go through that. So you will have hardware based ones, and uh, you they are like prone to not much, you cannot update them regularly, but you can do that with software based firewalls. Okay. Then a basic function of a firewall is to allow or disallow access to a network or a port. So here also, in case of firewalls similar to IDSs, you basically have some rules. You can define some rules, and based on those rules, you can allow or disallow access to the network or the port. Then there are firewalls which log attempts or to access a network or host. Basically, they monitor, and they keep saving the logs. Then they also act as filters. They filter any information the network packet headers. Like the packet headers have various information, right? The source, from where the packet is coming, and the destination where the packet is going, then on which port, which particular service it is meant for, right? All of this information is usually filtered and also parsed sometimes. So, but there are times when even the data content which is there, the part which is other than the header of the packet, is also parsed, because most of the time some malicious payload is actually there inside the data, right? Then this, yeah, I mentioned this term called demilitarized zone. So you should be aware of this. So normally, the part of internet which is facing the outside world uh, is the first one, and then you have a DMZ, and then behind that you have actually uh, the corporate network or the systems. So any IDS or firewalls are actually installed in this zone. Okay, they act like a very stringent defense system. Okay, and even the honeypots, they also reside only in this zone. So let's discuss some of the types of firewalls. So you have four or five, yeah, five types. So one is called packet filtering firewalls. Basic function of packet filtering firewalls is to filter the packets, examine their contents, and they use these rules to determine what action to take. Then second type is circuit level. Again, they filter the packet, but they don't examine the packet. These firewalls, okay, and they also monitor the TCP handshaking to determine whether a particular connection is a valid connection or not. So that same three way TCP handshake that we have been talking about. Okay. Then there are firewalls which are called stateful inspection firewalls. So they also examine each packet. However, additionally, they relate various different packets with each other. They have that capability. So they can understand whether these particular packets are related to one particular communication or not. Okay. But just because they have to process large amount of packet information, and they have to remember and do some storage, so there might be some network performance issues that you can face if you are dealing with the stateful inspection firewalls. Then there are application level firewalls. So application level firewalls have both packet filtering and some circuit level features. Okay, and they filter on service as well as other properties. They are good for security, but again, uh, they might have some impact on the network performance. And then there are multi-layer firewalls, which also have packet filtering and circuit level capabilities. Then they can enable the direct connection between local and remote hosts. They are also very good for security, but they might have some impact on the network performance. Okay, so now let's discuss about honeypots. Okay, so there are PCs, I would say, or machines which can be installed on even VMs. Okay, and they are made part of the network intentionally by uh, for attracting these attackers or the nefarious people. Okay, so generally they are like just dummies. Okay, but normally they have the capabilities of recording the activity of the person who is trying to log in or who is trying to attack. Okay, and they are like completely segregated from the actual information that resides in the company or a network. So basic purpose of these is to confuse the attackers or discourage them. say, like if you get into a trap of a honeypot, you might, invest your value, or basically I would say waste your valuable hours trying to understand as to why this system was created. Okay. So they also are used to limit the exposure to sensitive data. And then there is a term called honeynet, wherein multiple honeypots are there in the same network. So what can happen is like one honeypot is working as a mail server, one particular another honeypot is there on the same network which might be working as an application server. Another honeypot is there which might have features or ports that are related to database server, something like that. So normally these systems are created to attract and confuse or discourage the attackers. Okay, so let's discuss some of the firewall tools. But before going on to that, let's see the factors that will help you in choosing a firewall. So before selecting a firewall, you need to have an understanding between what are hardware based and what are software based firewalls. So as I mentioned, both of these have pros and cons, and sometime and most of the time you would see bigger organizations use both of these. Okay, it's just the level at which you apply it. Then also while choosing a firewall, you need to consider whether it is application based or not. Then always before selecting a firewall, we need to do a thorough check on the vendor. Why I am saying is that because there are times when if the background check is not done, maybe it is a firewall solution is given to you for just the purpose of actually learning more about you. Okay, and selling that data to someone else. Then ensure that regular support and update is there and provided in case of a firewall. And obviously the most important part is you should know the difference between a packet level firewall, a circuit level, and a state, like all other types that we have discussed. And we need to know that what all notification features they have or logging features they have. Why logging features is because when even if you have not been able to detect an attack and something has happened, but regular logging is there, then you will have a lot of data with you so that you can analyze it offline. Okay, and or at the later stages whenever you detect an attack. Then very most lastly, the most important feature is failover features. So a firewall needs to have failover features that even if it was down or it was made inactive, then some failover mechanism is there for it to come back up again. Okay. Then choosing a honeypot, some of the features that you need to understand are that what for what purpose a particular honeypot was created. Okay, so one particular honeypot might be specialized in dealing with the one kind of an attack. Okay, so it might work like some kind of a attracting spot, uh, maybe for novice level attackers, or it all depends on what kind of an analysis that has happened in a company, and based on that you can understand the purpose for which a honeypot, which for which purpose the which honeypot is good. Okay, and obviously you should consider the source from which the honeypot is you are purchasing. So again the same thing, like you should people are there who create these honeypots and they might sell it to you, and but with the purpose of collecting more information about you as well as the attackers rather than actually defending you. Okay, then obviously you should consider what other features a particular honeypot has and it provides. Some highly rated honeypots. Okay, okay, I'll just change this font because it's confusing. I've just kept that in a different font. Yeah. So some good vendors you can find out if you. Uh, I mean, these are the ones that people talk about in the industry, and some of these, if might not be there mentioned in the lab documents. Okay, and just have a look in the lab guide also. If they're there, it's good. Okay, then there's something. There's one brand called Honeybot. Okay, it's a Windows-based honeypot, and obviously, like if you have like Linux-based environment, then you won't consider a bot which is a Windows-based. So it might not be of any use to you, right? It simulates the several network ports, and it also has an inbuilt early warning IDS in it. Then there is a honeypot called Labria. It supports multiple platforms. So obviously, like if you have Windows as well as Linux platforms, you can use it. So because it will work for either, and it acts like a tar pit. So it's like it basically sticks an attacker with it and doesn't leave, and tries to collect as much as information as possible. And it also watches the ARP requests. Then there is the Honeypot by Google, which actually the special feature with Google Hack Honeypot is that it protects against the search engines. Okay, and it also which actually limits the attack vector because there is a technique called Google docking that we have been discussing. So there are various good ways of finding out information from the Google docking, and then using them as a different attack vector. Okay, then there is a brand called Kojani. Again, it supports multiple platforms, and it also helps in simulating an SSH server. So if like in your environment, if you want to basically monitor attackers who like to use SSH and shells, and they might, if you are like highly Linux driven, then it might be useful. And main feature is that it is written in Python, and basically if you know Python language and it's quite easy to learn, then you might as well go and try to make some changes. You can write your own scripts, and you can read the source code as to what is there happening inside the Kujani. Then there is a similar, honeypot called Conpot, which is like it supports multiple platforms, and it also supports like complete protocol stacks. Again, it is Python based, and which might allow you to have a look at the source and add your own scripts to it. So let's discuss some IDS tools. So before choosing an IDS, you need to identify your security needs. You need to determine the purpose for which you're going to purchase an IDS. There are times when you need not even purchase. You can actually make use of open source softwares such as Snort, then which is actually a host based IDS. And there is also a Linux. We'll discuss these some highly rated IDS software later. So, like, consider whether a particular IDS is application based or not. Then, also you need to understand what actually it monitors. So, you need to really research on the features that a particular IDS has, and determine, like, say, if you don't have enough capability to with you to for individuals to work on the source of the IDS, and you think that you would require like timely support, then you should actually see a commercial solution and see whether regular support is available or not. You can have that feedback also from others, right? Then you can consider deploying like more than one IDSs if required. Okay. Some of the highly rated IDS softwares, Cisco Secure IDS, which is like network based. It has the features of scanning, and additionally, it also can terminate the connections if it finds that something suspicious is there. Then a very flexible IDS software called Snort is there. You can also have a look because you can install in Linux as well as in Kali. You can make use of it, but configuring it and working with it would require a little bit of advanced techniques. You need to go through documentations and other tutorials. So obviously, it's a host based network intrusion system. Then there is again another Linux based tool called Aid. It's again host based file and directory integrity checker. Okay, then there is OSSec, which is for Unix systems. Again, it is host based. And then there's a brand called Checkpoint, which provides like several IDS tools along with that. Okay, so please have a look on this. Now, now we know like types. We know about IDSs. We know about firewalls, the types of firewalls. Okay, the level at which these firewalls are. Okay, how they're classified. Now we know about honeypots. What is their function? Okay, now let's discuss how to evade IDSs and firewalls while attacking a system. Okay, so some of the types of evasions that we would be discussing. First is payload obfuscations. Okay, so various techniques that are also mentioned below. Okay, that can help you in obfuscating. If you are thinking what obfuscation is, so it's like hiding something inside something. Okay, make something appear as something different. Okay, not the actual information is not revealed. This is not something which is similar to encryption or steganography, but something which is in plain sight, and you're just using mechanisms like encoding, okay, and also encryption, and sometimes polymorphism to basically make it confusing for an IDS to understand, because the rules that are written to obfuscate the information. Okay, so the term is like more like an umbrella kind of a term for which encompasses encryption and encoding in it. Okay, so then there is a technique called insertion and evasion. So if let's say there is an end system, there is an attacker, and in between an IDS is there. So if you use a technique, any technique you use to uh, for an IDS to take the packet, but for an end system to reject it, then it is called insertion. Okay, wherein you have actually inserted some information inside the IDS, which results in some kind of a change in behavior, and it allows the packets to pass from it, but and it might get rejected at the end system. Okay, then there is a technique called evasion. Like these are all are normally used together. So there is a in case of evasion, what happens is that you will actually evade the IDS, and the packet would actually reach the end system and will get accepted. Okay, so in that case, like you are just evading the IDS. You're not doing any manipulation in the packet so that it gets accepted. Okay, some of then there is the denial of service, like you found some vulnerability with the IDS, and you have caused some kind of a denial of service, created huge influx of data for it, and it started dropping the packets, and it is allowing some packets to pass through. So in that case, it is called denial of service type of evasion. So some of the payload obfuscation techniques, they are used to confuse or bewilder an IDS, and they are also used to hide the payload. So a technique like encoding, which is usually service dependent, and because different services have different encoding mechanisms. Okay, so that's why this technique is service dependent. Now, example is like you can hex encode, you can use octal or unicode to encode the information, and they are encoded in such a way that the IDS will not be able to understand it. And in same case, you can make use of algorithms like RSA and Blowfish to secure and make use of secure protocols to set up some kind of a tunnel between the attacking system and the actual victim, which is behind the network. So this basically this data cannot be read by the IDS, so it won't be able to understand it. And normally, and then they similarly, you can look into a technique called polymorphism. So with every kind of a request that you send, you actually create a different pattern. Okay. Normally, IDS what you have, they normally have a signature database, and they try to map the coming request and try to do a pattern matching. So if with every request you create a unique pattern, it will be very difficult for an IDS to understand. So what happens in case of insertion and evasion techniques? The IDS doesn't recognize packets as malicious. Okay, and uh, let's discuss about protocol ambiguities. Like you send the packets and they are handled differently on different hosts, right? So because a Windows or a Mac or a Linux, they handle these protocols differently. Okay, then an IDS may handle data different than a host, so that's why they it can actually drop a packet. So if you create those ambiguities in the protocol, then you can evade the IDS. Okay. Then there is a technique called low bandwidth. So you basically send your data over a long period of time, and an IDS will not be able to relate one packet, one data in one packet with the another one, because there is a time too huge of a time lag. Okay, but when it is reassembled at the end system, it will be reassembled. Then you can actually break if you break the payload into various packets, and which is like becomes which becomes unrecognizable. Okay, for the IDS. Also, this is also called session splicing, and if you use this kind of a technique, it is called fragmentation of a packet. Also, you can jumble the fragments in such a way that some information in one packet is duplicated in another packet, and an IDS might not be able to reassemble it correctly. Okay, so you can use overlapping fragments also. So this is what happens in case of insertion and evasion techniques. Okay. So with respect to denial of service techniques, okay, what you do is you find the vulnerability, and you create huge influx of data for the IDS. Okay. Basic objective is to prevent it from doing its job. So let's say if there is a you can create an operator DOS, wherein if someone a human being is actually monitoring the alerts or errors, then you can create like huge amount of alerts and errors, so that the person will get confused, okay, whether which one is right or which one is actually wrong data, or what kind of error it is, because sometimes what happens is these IDSs also create false positives. Okay, so it will become difficult for an operator to make or differentiate between them in case of a denial of service. So that might actually let the data pass through. Then CPU DOS, wherein you create too many packets, uh, so that the IDS on which wherever the IDS is installed, you will actually overwhelm the CPU buffer. And so what IDS would think that uh, it's okay. There is a limit for it to parse the data, so it will allow some payloads to basically go without actually parsing it. Then you have memory DOS, wherein you can overwhelm the RAM with too many connections, and one particular connection actually requires some amount of RAM, right? So, and if there is too much of a load on RAM, so it might also bring down the IDS. Okay, so by the time it recovers, and if there is a failover, so during that time, then the data can pass through. Now, in case of firewalls, before actually evading a firewall, you have to first understand a firewall, and because as much as you know about a firewall, it will help you in evading. So, and every firewall is different. Like they have different features, they have different techniques. So, collecting a lot of information about a firewall is like quite important to basically evade a firewall. So some of the techniques that can help you in identifying a firewall type is port scanning. You can scan the ports, and there's a very interesting term called firewalking. Okay, that is also there. What happens in firewalking is that you make use of trace route, okay, and time to live, and then you understand as to what kind of services are actually running. Okay. I have not done firewalking, but I've just read about it. So try reading about it. It's a very nice and interesting one to go through. So then there is a, technique called banner output. This you must be aware of, right? So you basically send out a request and then you connect to some kind of a port, say a telnet port on which the software is listening, and you send some command, and it sends back an output telling about itself, right? So you can grab the banner and you can know about the firewall. So once you know about the firewall, then you can like research more and understand how it works, its different features, and then you can plan the evade or how to bypass it. So there is one technique called tunneling. What happens in case of tunneling is that you hide one protocol inside another protocol, right? So it's like you can use ACK tunneling, you can use ISMP tunneling, SSH tunneling, and HTTP tunneling. Okay. So in case of tunneling, what happens is that only the end systems would be able to understand the communication, the system which is on the attacker's end and the victim. Okay, only those will be able to understand. Then another technique to evade firewalls is changing the source. So you can actually, by changing the source means the IP address or the source address from which you're attacking. Okay. So you can get entry into an authorized external system which the firewall doesn't block, and you can spoof that and then get an entry into the network. Or you can make use of a proxy server, and also sometimes if an anonymous web surfing server is there, then you can go through that, or you can apply source routing technique. So you can basically collect a lot of information on the network, all of the devices which are there, and these firewalls are usually on the devices in between. So if you know that a particular software or a monitoring software is there on this device, you can remove it from your safe route to the end system, and you can just predefine the route through which the particular attack would travel. So that is called source routing. Okay. Then There are some other techniques such as man in the middle. Okay, you can sniff the network, and then you can have, or you can basically have a, you can create some kind of a mail and send to some employee in the, by using social engineering technique, and have them click some kind of a link, and they would actually initiate a valid connection, and then you can make use of that. Okay, and you can also read and research more and query firewalls more to find other loopholes which can help you in evading it. Some of the tools, so some these port scanners that we have been discussing during this course. So we have discussed Nmap, we have discussed Superscan, NVIP scanner, and Unicorn scans, right? So we can make use of these port scanners for scanning, and some tunneling tools that you can make use of. There are HTTP port. Sorry, I pronounced it wrong. HTTP port. So it's make use of HTTP to create a tunnel, right? Then there is a super network tunnel. Again, there is HTTP tunnel. It makes use of HTTP. Then there is Bitwise. I think Bitwise uses SSH for creating a tunnel. Then ACT command uses ACT protocol to create a tunnel. Then there is low-key ICMP tunneling. So it creates an ICMP tunnel between, and tunnel is like the traffic is encrypted and it cannot be seen by the people who are outside the tunnel, right? Or monitored by these softwares. Then some of the packet fragmentation tools, you can use NetScan tool, fping, hwing3, packetgen, packet generator, and mgen. So these can help you in fragmenting the packets, right? Some of the techniques that you can use to detect the honeypots. Okay, so always remember, by their very nature, it's very difficult to detect honeypots and to discover them, because they are designed for that. Like they are designed to be exploited. Okay, and if you are like, if you're taking initial steps, you might fall into that kind of a trap. Okay, but generally they actually only record information. There is no counter attack that is sent back to you, right? But that these kind of systems help the organizations learn about various kind of attacks. Okay, and it's best to basically read about various type of honeypots. The I have already mentioned these some. So you go read about them and how do they work. Okay, so if you know how do they work, so while actually being there in the system, and if you are there and you got a foothold and you're looking and trying to understand whether there is a file system or not, uh, what kind of services that are there which are running, if you see some kind of unusual responses. Okay, so you, or there can be some additional responses from it, which you actually read about when you learned about the honeypot, when you were reading about it, when you were learning, you yourself were learning about it. And these techniques can help you in understanding. There might be a system which has like too many ports and services that are running. So yeah, it should raise some kind of a concern in you, that you should make you suspicious, that yes, like maybe I'm part of a, like I've got into a honeypot or a honey net. Okay, and then there some unusual responses is like you can see like when you're querying and you're looking for a three-way handshake, but it is not happening, but the port is like listening and open, and there is no other response, then it should raise some kind of concern in you as an attacker, as to probably you have found a honeypot, right? So for pen testing the IDSs, firewalls, and honeypots, for testing the firewalls, like you need to scan. You can become an like man in the middle. You can spoof IP addresses. You can make use of proxy servers. You can fragment the IP packets, and you can make use of tunneling methods. So these are some of the methods which you can use while you are pen testing, while you are planning. And we have discussed all of these terms in our like previous sessions, right? Then for while testing the IDS, first you read more about IDSs and try to practice that what techniques can help you in identifying it, and then try to evade it. And if it is becoming impossible for you to evade it, then you attack it. So for attacking, you can actually launch a DOS, a DOS attack. For that, you will have to find out some kind of a vulnerability, and then if probably use social engineering technique, get a valid session and create a DOS. Okay. So we have reached the end of this particular session. So what these are the like points that we have discussed. IDS is a security software or hardware device which inspects network traffic. Okay. Then firewalls are also software or hardware based systems. They're used for allowing or disallowing the access. Then a honeypot is an information system resource for attracting or trapping the attackers. Okay. Then attackers can evade the IDS and firewalls using techniques that we have discussed, such as sessions splicing, fragmenting, increasing the time to live, or spoofing the IP addresses, using tunneling methods, hiding one protocol into another protocol, these protocols that we have discussed, and then MITM. Attackers can determine the presence of honeypots by the techniques that we have discussed. You need to read more about honeypots, and while you are there and interacting with a honeypot, you will be able to know that it's a honeypot. Then all the techniques that we have discussed can be made part of your pen testing, and these techniques help eventually when you prepare a document and a report and you submit it to the concerned people. They help in evaluating the existing firewalls and IDSs, and then update the rules, or maybe log some issues and get those fixes from the support and all. Okay. So that is it for this session.